Hey you! Don't watch that! Watch this! This is the heavy, heavy monster sound! The nutsiest sound around!
Let's consider the number 12 and all the numbers that can divide 12 without giving a remainder. Well, we know that 12 can go into itself, which will give us 1. And we know that 1 can also divide 12. Now 12 is an even number, and all even numbers can be divided by 2, so 2 can also divide 12. If we divide 12 by 2, we're going to get 6. So 6 should also be able to divide 12, because 6 into 12 is 2, yeah. 3 can go into 12. And if I know my 3 times table, 3 4s are 12. So these are all of the numbers that can divide 12 and not give me a remainder. These numbers are called the factors of 12. 1, 2, 3, 4, 6, and 12. The smallest number, which is a factor of 12, is 1, and the biggest number is 12. Let's look at another number. Let's look at 15. And all the numbers that can divide 15 and give us no remainder. Well, we know 15 can divide itself, and we know that 1 can divide 15. 15, it ends in a 5, so that means that it should be able to be divided by 5. So 5 should be a factor of 15, and 15 divided by 5 is 3. Again, notice that 15 has at least 2 factors, 1 and itself. So the pattern here is that every number has at least 2 factors, 1 and itself. So 12 has 1 and 12, 15 has 1 and 15. Let's look at another number, 8. What are the factors of 8? Well, based on the pattern that we're seeing, 8 should have at least 2 factors, 1 and 8. Now 8 is an even number, which means that we should be able to divide it by 2. So 2 is a factor of 8. And 2 times what will give us 8? Well, 2 times 4. So 4 is a factor of 8. And there is another pattern. Not only do each of these numbers have the number 1 and itself as a factor, but we can start to see a pattern where we can combine these numbers to get our original number. 1 times 12 will give us 12. 2 times 6 will give us 12. And 3 times 4 will give us 12. 1 times 15 will give us 15. 3 times 5 will give us 15. 1 times 8 will give us 8. And 2 times 4 will give us 8. So there seems to be another pattern where the factors come in pairs. Let's see how that can help us some more. Suppose we have the number 14. Based on the first pattern we noticed, 14 should have at least 2 factors, 1 and 14. Now, 14 is an even number, which means that it has a 2 as its factor. Now, 14 is missing one last factor. And how can we figure that out? Well, we can pair our factors. We know 1 times 14 will give us 14. So then the question is, 2 times what will give us 14? The answer is 2 times 7. So 1, 2, 7, and 14 are the factors of 14. But let's look at this tricky one, 9. A lot of students say that 9 only has 2 factors, 1 and 9. 9 has 1 and 9. But those are not the only 2 factors. 3 can divide 9. And then you may ask the question, well, based on the pattern that we've seen before, 3 should be able to pair with some other number to give us 9. The fact of the matter is that 3 pairs with itself because 3 3s are 9. 20. 20 should have at least two factors, 1 and itself. Because 20 ends with a 0, it's an even number, so 2 can divide 20. Now that we have 2, what number can multiply it to give us 20? 2 tens are 20. We're missing two numbers. If you know your 5 times table, you would know that 5 4s are 20. So we're missing 4 and we're missing 5. So before we go, one last thing to note. You'll realize that the biggest factor for each of these numbers is the number itself. And none of the factors are bigger than the number we're looking at. So 20 is the biggest factor for 20. 9 is the biggest factor for 9. 14 is the biggest factor for 14, and so on and so forth. So with that being said, I want you to find the factors of these two numbers.